Hey guys, welcome to the review of the Cutting Edge Power 500 watt power station. Was sent to me by the company, and they wanted me to do a review in exchange for some exposure from my channel and a review. So I'm very excited. This is a USA made solar generator, and I don't think I've ever used one of these before or used any USA made product before that was a solar generator. This one is very unique, it's very expandable, and I'm really excited to show you guys what it's all about. So let's go ahead and get into the product details. All right, so I just wanted to go on the Cutting Edge Power website and show you guys what I got. I got the 500 watt Pure Sine Solar Generator, and this is the exact URL. There's one that is a little less, and I think it's just because it has a different inverter. Clearly the inverter I got doesn't look like this one. It's the Beltec one. So yeah, that's just a heads up there. But the main things I wanted to show here have to do with what you can get it with. And we have different battery options. So you have lithium battery you can get, AGM, and then sealed lead acid. Those are just 3 options there. And then we also have solar panel options. So if you wanted to get solar panels, you can just add these as well. So that's pretty cool. They have a bunch of different kinds. And then the charge controller is the one it comes with. But then you can also get the MPPT, and it has Bluetooth, which is pretty cool. So you can connect it with your phone, and it probably has an app where you can review the input power and all the settings. And you can get 2 of those if you want to really maximize it. And then wind turbine controls. They sell a bunch of wind turbine products, so I haven't looked into it, but that's a pretty cool option. And lastly here, I want to just talk about the different battery chemistries that you can use nearly any kind of battery. So you have the whole list here. I'm using lithium iron phosphate for me. So yeah, I just wanted to show you the different options available. I got the very basic. I didn't get anything. I just got the basic package. So it's going to be the same price as shown here. All right. Here we go. So positive terminals first. So this is not the easiest process because I have to hold this bottom part, but I could just put it upside down. Okay. Take this off. I'm gonna just flip it. Carefully put it down. All right, and then let's look at the negative terminals, or the positive ones first. We have 2 of them, and then there's a strap here for one of them. I'm just gonna undo it and put this aside. So we've got 2 red terminals right here. So screwing this in, I forgot I have to include this other one. I'm getting these 2 together. It'd be a lot easier if I had a wrench or something, but I'm just gonna do it homemade. Now the negative one, I might need to wear some protective gear. So I think I'm gonna go ahead and find some sort of gloves to use that with. Screw that in. Now when I do the negative to negative, this is where I might see a shock or just a little spark or whatever. But yeah, this is where I just recommend taking precaution. All right, so I put on some gloves, which I probably should have done in the first place. But here we have the negative terminals. I'm just gonna go ahead and put these in. Connect these together. There you go. Got that little spark. Okay. Now they're plugged in. I knew that. I had a good feeling that was going to happen. The inverter button was on. That's the little fan thing that was going. All right, so this is in. Yeah, and so now I'll just go ahead and put it battery back in. And the battery's at 13.0 volts. So, check this out. Shows the battery voltage right there. So exactly what it said on my screen. The battery I have has a little screen. So what turned on was this inverter switch. So it was already on, I didn't see that, but you'll hear it. There's a little light that turns on. And the battery voltage just went to 12.9. All right, so the battery's charged to 13 volts, just about, and I'm gonna first test the USB ports. I'll start with the charge controller one. It's just 5 volt, 1 amp, and then the other two are right here, and I'm pretty sure they're the same thing, but we'll see how they perform. Let's start with the charge controller. So plug this in, and then I'm gonna charge the Sherpa power bank, so you guys get a good idea of the exact wattage coming in. All right, I'm just gonna go ahead and put it in, see if it works right off the bat. Usually it doesn't, but it is. So you can see 5 watts are coming in. So it works, and you can see that the battery down here went to 12.9 volts. So let's go ahead and get to the other USB ports. Now I'll have to go to the I'll have to turn the inverter on. You can see the USB ports are down here. Now they are auto 0 to 2.4 amps. So we'll see how much power I can get. Hopefully I get more than 5 watts. So I'm gonna go ahead and just turn this on as soon as I'll just plug this in first. Okay. So turn it on. So you could hear the fan lowered because there's not a lot of power being drawn, but this right now is the normal fan noise. It's slightly louder than the other systems I've had, just because the inverter is it's not inside the actual box, but it's kind of a white noise right now. So as you can see, actually it is powering. I forgot I kept it plugged in. 12 watts coming in, so this is a nice charge. Obviously it's better than that the charge controller one down here. So 12 watts coming in, and then I'm just gonna go ahead and do the other one. Let's see if the fan noise goes down. Nope. So that's the consistent noise. All right, this is literally just to test the other port and just make sure it's still producing the same amount of watts. And it looks like it's going to build to 12 eventually. And there you go, 12 watts. And now I'll go ahead and test both of the USB ports at the same time. All right, so I'm just going to charge my phone that's plugged in filming right now. All right, so I just had to unplug my phone cord and plug it back in again, and now it's charging. I can't give you the exact watt reading, but I can still show the Sherpa and make sure that one is still getting 12 watts. So what's good is that my phone is charging, and this does not lose any of its input power, so it's still going to charge at the same rate. So that's good to know. So the USB ports, they work just like advertised. Obviously these ones output about twice as much power and a little more than the little charge controller one. So there you have it. Let's get into the AC ports. All right, so I have the Jackery Explorer 1000 here, and I just want to charge it from the inverter here. I think we'll get about 150, 160 maybe watts coming in. So I'm just gonna go ahead and turn the inverter on now. And you can see on the left. Okay, and now we have the light for the adapter. Now I'm just gonna go ahead and plug it in. now it's in. Okay, you can see it just turned on. And I don't know if you could see it very well here, but we're at 120, 30, 40, 144 watts. So yeah, pulling 144 maximum right now, touching 145. Alright, so the inverter fan just kicked up. There's no fan blowing, there's no airflow in this office, and it's kind of humid down here, so I don't think this would happen all the time, but in my case, I'm sure that it's just trying to cool down the elements in the inverter. So you can hear the fans kind of loud. I kind of expected that because I've experienced these before, but besides that, it's charging it just fine. So now we'll go ahead and see if I can pick it up and get closer to 500 watts. Alright, so this may not be the best idea, but getting kind of desperate as to what I can use for 500 watts. And I'm going to charge my EcoFlow River Max power station, which uses this AC charger, and it could input up to 500 watts, but I don't know how high it can go. So let's go ahead and just test it with this, see if it works, and if not, we'll figure out a solution. So I'm gonna go ahead and start it up right now. Okay, I'm gonna turn the inverter on. Sounds good. All right, here we go. Just plugged it in. It'll take a second, and then we'll see if this inverter can handle the amount of input required. All right, slowly going up, which is okay. We're getting up there now, and hopefully we can stop somewhere so I can figure out what else I need to power. Here we go. So that louder sound is coming from the inverter right here. And if you look down here, you can see the battery voltage is down to 11.6. All right, now the inverter fans are really going high here, because now we're going up to 300. And it looks like it's still increasing, just very slowly. So I apologize for the loud noise, but I just want to get you a sense of how much power this can output. This battery's starting to get lower, so definitely want to charge it up soon. So 312 watts, and it looks like it just started going down a little and fluctuating here. So, I mean, the fan may not always be this loud for this piece of equipment. Once again, it's pretty humid. Oh wow, I didn't even realize how high it's getting. I knew it was going to get high. And you can see the battery icon is signaling that it's low. Oh, we have an error. But it's still, the inverter is still able to output. Look at how high it's going. This is insane. I'm going to have to turn it off soon. But let's see if we can get it to 500. And error. I had a feeling something was going to happen. I took a risk. But I'm going to go ahead and unplug it. First things first, we got to see what that error code is. But actually, I'm going to go ahead and see what my battery can handle. I don't think my battery is capable of outputting so much power. So I'm going to go ahead and turn the inverter off. Oddly, after I was packing up the EcoFlow and just putting it back, it just self-corrected, and now we're at 12.7 volts still, which is strange to me. I thought we were down to like 11 something, but I guess now we're at 12.7 volts, so maybe it was just outputting a lot of power at the time, and now the voltage is returned. So yeah, I don't really know what happened because I didn't see it go back, and then suddenly when I was about to fix the error or attempt to, it just went back. So I'm gonna still open this up and check the maximum output that the battery can do. All right, so here's the manual for the controller. You can see that the error code, which was the E01, over discharged, and then the battery has been discharged below normal ranges. So and it says recovered once battery voltage returns to normal range. An alternate charge source may be required depending on depth of discharge. So my battery, and I'll just go ahead and lift this, it says 12.7 volts right now, and I actually also have a little screen on here that says the voltage is, if the screen would adjust, it says 12.8 on here. Sorry if you can't see that. That was kind of a crummy view. But the battery status symbol is also low on that. This battery is actually pretty small. I think it's 288 watt hours. So I understand if the battery cannot support that amount of output wattage, and that was actually my fault for not actually thinking that battery through. However, I did want to test the inverter, so you can probably get a lot more power, or at least more consistent power, closer to that 500 watt range if you have a larger battery than my battery, which is 12 volt 24 amp hour one. Yeah, you could easily fit a bigger battery in this box, and I'm sure that this little tiny battery is not the ideal one. So that was my own battery, so they can install whatever you want basically. So that is pretty much what happened here. However, it did get up pretty high before the error message showed. I just wish that I got a better sense of when it would shut down, but I shouldn't have tested it with that. All right, guys, so I have the solar panel here, and I'm going to use that to charge the cutting edge power. Now, this is a super large solar panel. It's 180 watts, so I'm going to go ahead and hook it up and see how it works. So I just connected them together, and the only difference here I can see is that the solar panel lit up, and now it says it's transferring energy to the battery. It says boost. See that? So that looks like that's the boost phase. So the battery's pretty low right now, and I'm guessing boost just means it's capable of inputting as much power as possible. This is a PWM charge controller, and I know that PWM, some people don't like them, but they do have their own uses in good ways. It just doesn't charge as efficiently as MPPTs. However, this one is charging fine right now. I should mention that this company also has MPPT charge controllers, so you could browse and see which one is ideal, but for this one it came with a PWM. I want to see how many watts are coming in, or if I can get any other readings besides what I see here. So I'm just gonna hold this. I'm not sure what 97% means. The battery is definitely not at 97%, so I'm not exactly sure what that's reading. $14.2. I'm just gonna, charging voltage is 14.2, so that's pretty. We're charging watt. It says charging, yeah, charging V. So that's actually a really good charging voltage, and it could be because I have a very high-powered solar panel. 0 watt hours. I don't know why there's a 0. And we have 0.8 amps. So it's charging pretty slowly, and that's because there's pretty heavy cloud cover, but this is a really heavy solar panel, 180 watts. So it's still pulling in, what is it? So we're getting about 25, 30 watts. And the sky's pretty gray out. So I'm actually kind of surprised. But yeah, we're charging up decent. But you see the battery is now at 13 volts. So yeah, it looks like it's charging at 14 point something volts, but the battery voltage right now is at 13 from like 12.7 earlier. So now we're finally getting a little sun, but I mean it's just a pocket. So I'm just gonna keep an eye on this and then see how much we get this charged up. Alright, so I'm just going to connect this 180 watt solar panel to here to charge this baby up. We'll start with the positive. Okay, go negative. There we go, now it's fully in. We're at 11.2 volts. You can see that it's quickly gaining. There we go. Yeah, now the sun's coming out. Let's see the sun here. Yeah, so it's pretty cloudy, but it's thin clouds right now. Sun's like straight up. Alright, so now we're already at 11.6 volts. And you can clearly see the different elements here. Let me try and zoom in. So we're at boost charging on the left. And then this just indicates clearly that it's charging the battery. 12 volts, should be set to lithium, so we're slowly picking up. This battery is really low right now. So the panel I'm using is the Bouge RV panel, which I'm going to review pretty soon here. And you can see the maximum power is 180-ish watts. Open circuit voltage. So everything's within the PWM controller's range, since it can handle up to 450 watts. So as big as this panel is, it's actually not too big for this controller. So there you have that. Now let's check on the panel here, the charge controller. So it's charging pretty quickly. Alright guys, so that concludes the majority of the testing that I'm going to do on this system. Now I still have a few things that I have to work out, and one of them are is the charge controller. I have that in here. I have to work on the settings because I still wasn't sure after I did those short tests if my battery was charging correctly or not. For future testing, I'll most likely do another video on this just to run through a second round of testing and make sure everything's working properly. I think overall the system is well designed, and it's I said not overly complicated because it's not like a Goal Zero or Jackery or any of those brands that are plug and play. It's not overly complicated. Works pretty well, and I think that this is a system that can work with a lot of people that are I would say maybe a little more than just brand new to solar generators, because you just have to still have a few settings and know what you're doing, but it's really not that bad for someone who's a little more than just a beginner. Next here I have, you can fit it with your choice of batteries. So that's just one of the many things that you could do with this in terms of expandability or customizing it. You can fit it with any type of battery, as I've shown before. Next year I have the voltage sag from when I was using the inverter, the AC cord to charge my other power station, and it went to like 400, almost 500 watts, and then it shut down or I had an error message. That was because my battery is too small. If I have a small battery and I'm trying to get a ton of power out of it, the voltage is eventually going to get too low to where it can't support the amount of power needed to do what I'm trying to do. So in that case, it was way too much power for that battery, and the voltage was way too low. If I had the same voltage battery, like a 12-volt battery, and it was like 3 times the size, then it probably would not have had that error message. So that's something to keep in mind, and that's the reason why that happened. It was because my battery was way too small. Next we have I already talked about the charge controller. Next here we have the LCD screen doesn't turn off. This is just something I ran into, and it's also because I have a smaller battery. If I don't charge it within about a week, the screen is going to be on all the time. There's no like off switch button. So it takes a very low wattage, but it still takes power. So that was just something I noticed, but I'm pretty sure if I get a bigger battery, it's not going to be an issue. Next here we have comes with battery car charger. So I've tried this, and I don't think I had it in this video, but it's basically a cigarette lighter port, and you're supposed to plug it into your port, and then there's ring terminals for the battery, or you just put it on the outside terminals, and it's supposed to charge the battery. I tried that, but I didn't have anything else besides my EcoFlow River Max, and I think the River Max, it like shut down. I had an error message because it wasn't able to, I think, detect like how much power it needed to provide to the battery. So it didn't work, but that's yet again another thing I need to do in like a part 2 of this power station. And next here we have this is just me giving you a general idea of what you can power with a 500 watt inverter. They're all different and they consume different amounts of power, but those are just some examples. I know there's a million things I could list here, but I just wanted to give you a general idea of what 500 watts can do. And then I recommend bigger batteries, and the reason why is because of that voltage sag I just mentioned. If you use a smaller battery, it might not work that well with any of these, especially if you're going to run them for like a longer period of time. I think they sell 1200 watt hour batteries, which are like more than fine for this. It would work great with one of those, and you can even go with something a little smaller than that too if you want. And lastly here, why would someone get this cutting edge power solar generator over something like a Jackery Explorer 500? Like the Jackery Explorer 500 has a similar amount of watts of output from its inverter. It has a bigger battery than the one I put in, but the reason why I think someone would get this over that is because of expandability. So not only does this power station standard by itself have a 450 watt charge controller, which is I think like 5 times more than this Jackery Explorer model, but it also, you could expand the battery, and you could really just go nuts with the battery if you wanted to and just get a ton of them, and that's something that you will not find with this Jackery Explorer 500 or a similar power station like that. And then secondly, you can customize your own. So there's other accessories that you can get on their website. You can get like a USB-C port installed in it, and I think it's $40-$50 added on, but you can customize it in the MPPT. You can, if you don't want the PWM, you could get upgraded charge controller that has Bluetooth, and there's other things you could do as well, but you can customize it and make sure it fits whatever you need and or prefer. So that's something that is unique to this. Lastly, here I have that it lasts longer, and the reason why is because if you were to use something like a Jackery Explorer or one of those other pre-made sort of power stations, once they run out of the battery life cycles, there's very few of them that have replaceable batteries. You're gonna have to get rid of it once it's after its battery is all depleted. So that's something to just consider, is that with this power station you can just replace the batteries and it's going to be fine. It just makes it something that's more reliable long term and worth the investment. That's pretty much everything I had for this review. I hope you guys enjoyed it. I know I didn't get into everything and get every detail nailed down, but this power station is totally different than what I'm used to, and it will take me a part two to really get into the details of it and work with it a little longer, so I can show you guys what I learned and find out. But yeah, I recommend checking out their website. You can check out whatever you're looking for. I mean, this is a smaller solar generator, and the one that they have, this one is a 2,000 watt solar generator, so it has a massive inverter. That's just one of many, and they have some really nutty ones too. Like this is 240 volt split phase, so you could run like your oven or something with this. So I would check it out, see if you like their products or are looking at something that's in this field of solar generator. But it's very unique, and I always really appreciate the Made in USA point that these guys are a part of. They're based out of Houston, Texas, and they assemble everything in the USA. They try to find as many parts as possible that are manufactured in the USA, and that's it's hard to do, so they can't do it with everything, but it's just pretty awesome that they're actually doing something like that in wanting to keep things made in the USA. So I respect them for that. And yeah, so I have a thumbs up for this power station. Still have more to learn, but I really like it. And I'm going to have a review blog post about it, which I'll just get into more details and lay out the specs, maybe some nuances that I haven't discussed here. But if you enjoyed it, please give me a like, and then let me know in the comments if you would prefer something like a Jackery power station that's probably a good amount easier to use, easier to handle, or would you rather have this where you can expand it? It will probably last a lot longer, and it's more easily, the components are easy to replace if anything were to happen to them. So yeah, I just want to see what you guys have in mind about that. So I'll see you in hopefully the next video, and have a nice one.